Here's a new display module. So similar to the larger unit you saw earlier. It's in a instrument case. Has a few more features than the other one. As an example, got some DB9 ports on the back, and on one of them I've got the header pin, so you can plug in the older stuff and get it to the header pin DB9, 2 inputs, and a switch select between the header, the DB9 port, and an internal wireless module which communicates 4800 baud. At the moment the heater has a wireless transmitter that sends to the unit, and it's selected to wireless mode at the moment. Cords, and switch on the front, and there's the input source. There we go. That first display at the start is a qualifier character. It receives them to trigger off the wireless. You can see it's sending out the temperature and function the fan heaters in. The adjustment. And it changes mode. My old unit's a bit on the needs some repairs to it, but this is essentially my second prototype. Uses the same registers to drive the displays, however to address them it uses 74HC595, which is a logic level version of it, which will drive the strobe lines. It's obviously some small changes to the circuit. So in the old one, over here is the display for my large unit using 170 odd green LEDs. You see it on the side there, arranged in 7 segments, using kiwi patch boards. And this will be attached to some more registers and control the unit, and we'll be driving 60mm high displays. I'll probably attach my clock to that, because attach the clock to that, have it display the time, using the smaller unit there for miscellaneous functions. Driver. get inside the unit. There's a board there with the power registers which drive the displays, and the wireless unit is attached to the back end of it, and logic and supply. This camera there we go. Your logic and power supply. The ribbon cable is strobe and data clock lines for the register there. Turn my fan heater off. And you got your ports on the back. There's the aerial for the receiver. Simple power supply arrangement. It'll run with AC or DC, so it's pretty rugged in that respect. Uses the UCN 5841s for the display drivers, and on the front there, some LEDs just blink when data is available on the displays, using the switch to select which source you've got. And it blinks in time with the data it's receiving. You can see there's a little bit of a lag, so when it flashes, when it changes. The code on the PIC-AX will receive the ASCII values from the PIC-AX at 4800 baud and decode the ASCII values to a display code which lights the segments, and you can easily change the values for each number or digit or symbol with some simple code. You just have to change the value it assigns to it. Each display is essentially a binary readout, and I'm sure here each segment of the digit is assigned a value. 1, 2, 4, the decimal point's 8, the middle dash is 16, 32, 64 and 128. Add up a bunch of those numbers together, and add those numbers together, and you can create displays. And